All right. So recently, a company has decided that they are consulting with you regarding a box that they want to use for their merchandise. Basically, what's going to be a better design. So they've already come with kind of two options. The first box measures 8 inches by 6.75 inches by 10.5 inches. The second box measures 9.25 inches by 5.25 inches times 11.75 inches. Okay, so we're talking about a standard box design. Okay, we have our width, we have our depth, okay, and we have our height. Okay, and in each of these, we can identify kind of our width, depth, height. Okay, same for below, width, depth, and height. Sorry, width, depth, and height. Okay. It doesn't really matter kind of which order we're doing those in, but what we do need to recognize is they're asking us which box requires less material to make. Okay. Now, typically, when I'm seeing people, with width, depth, and height, and they know that they're dealing with a rectangular prism, they're going to be thinking about either area, as in surface area, or they're going to be thinking about volume. Now, many times, volume is an easier one to do because for a rectangular prism, we're talking about width times depth times height. Okay. The problem there is we're giving information that's basically going to become inches cubed. Okay. How much space is actually inside that box? Whereas our surface area is basically 2 times our width times height plus width times depth plus height times depth. Okay. The reason we have that too, of course, is because we have our 3 sides, okay, but the top has a bottom, the right side has a left side, and the front has a back side. Okay, so this is actually calculating like how much of that do we need. Now, to do this, we're basically solving the surface area calculation 2 times. Okay, the first time for the first box. Okay, so box 1 equals 2 times parentheses 8 times 6.75 inches plus 8 times 10.5 inches. Okay. All of those are inches. I'm going to skip those for now. And then 6.75 times 10.5. Okay. Box 2 is the same concept, just different numbers. So 9.25 times 5.25 plus 9.25 times 11.75 plus 5.25 times 11.75. Okay. Now, know that multiplication, order of operations, is these are basically getting grouped together within the parenthesis before they're added within the parenthesis, and whatever comes out of that parenthesis is basically getting multiplied by 2. Okay. So, calculator-wise, 2 times parentheses 8.75 times 8 times 6.75 plus 8 times 10.5 plus 6.75 times 10. Okay. And again, having it, fully parentheses, the full equation, that as long as you're not making typos, like this is giving you kind of the full equation. Okay. And that tells us that box 1 has a surface area of 417.75 inches squared. We repeat the same process, 2 times 9.25, or well, parentheses, 9.25 times 5.25 plus 9.25 times 11.75 plus 5.25 times 11.75. Okay. And again, we can, some graphing calculators, some software that you see, did you type in the equation correctly? And we did this time. So box 2 has a surface area of 437.875 inches squared. So when we're asked which box requires less material to make, well, box 1 seems to be the answer. Okay. Now, because we like to have kind of some complexity to our questions, okay, we do need to recognize that there's a second part to this. Okay. So in this case, we're going to assume that cardboard, the material that's going to be used, costs 0.012 dollars per square inch, okay, which is basically going to give us a conversion factor. And we're using the box that we just analyzed, so box 1, and its size of 417.75 square inches to determine what's going to be the cost. Okay. So, as mentioned, this is basically a conversion factor. We're basically saying 1 inch squared is equal to a dollar value of 0.012. Okay, so just over 1 penny. Now, in a conversion factor, okay, we're taking basically our base value. Okay, in this case, we know that we're starting with that 417.75 square inches, and we need to multiply this. Because we want to get rid of the square inches, okay, we set it up as a fraction. 1 square inch is going to go on the bottom, and on top, the 0.012 cost. Okay, square inches cancels out. Okay, that means that when we multiply this out, we're going to get the value that we need. So in the calculator, I can go ahead and just grab that 417.75 times 0.012, and this means that our cost, okay, is $5 and 0.013. Okay, so here's something to consider. Okay, and this is where it's more of a manufacturing concept than kind of an economic. Okay, usually we would go ahead and round this off. Okay, so we would kind of drop that 3, but the reality is, because we know that we're going to be producing hundreds, thousands, tens of thousands of these boxes, we're going to care about that small number, because as the number that we make increases, the number that we actually, the cost actually starts scaling up. So we talk about 10 of these, that may only be 3 cents, okay, scaling up, but 100 of these, we're talking 30 cents, 1,000, we're talking about $3, 10,000, it starts adding up. And at some point, someone's going to start wondering why it's costing $300 more than what you may have already said had you rounded it down to that $5.01. So, hope all of the ideas help here. It is again, a common thing to do where you have to evaluate, which is going to be the better option. So keep in mind, volume is not going to be the same thing as surface area. Okay? Pay attention to what it's asking, because if they ask which box is going to give you more space, you would probably have to go with the other box. You'd have to check those values. Now, it's not always going to be true, but you have to check the data. Okay? Here we can see surface area, and we can then calculate the cost. So again, piecing different ideas together, but if you have questions, leave comments, and I'm always willing to help you out.